Hi guys. Okay, today we're here to talk about measures of spread. So we have been talking about measures of central tendency, where the center of the data is, things like the mean and the median and even the mode. But that doesn't give us the whole picture. It doesn't tell us how spread out the data is, how close the data is to the mean, how consistent the data is. So this is where the measures of spread come into play. One of the measures of spread is called the range, and the range is found by the formula max value minus min value. So the range of the values is just the highest minus the lowest. So let's look at two different sets of values, two different sets of data. Let's find the mean for each of these. So we're going to find the mean for set A. So what we do is we add up 9 plus 12 plus 14 plus 14 plus 10 plus 13. I'm going to go get my handy dandy calculator over here. And it's 9 plus 12 plus 14 plus 14 plus 10 plus 13. I have 1, 2, 3, 4, 5, 6 pieces of data. 1, 2, 3, 4, 5, 6 pieces of data. Awesome. My total is 72. And then I'm going to divide that by the 6. So my mean is 12. Okay, our data added up to 72. We divide by the 6 pieces of data, and our mean is 12. Let's do the mean now for set B. So we're going to go back to that handy dandy calculator. This time we have 24 plus 9 plus 0 plus 13 plus 11 plus 15. Okay, and we got 72 again. And there were still 1, 2, 3, 4, 5, 6 pieces of data. So when we divide by 6 again, we're going to get the same mean because they both added up to 72 and they both had 6 data sets. So the average for both, or the mean for both, is 12. Well, that means that the mean of set A equals the mean of set B. So on the face of it, you would think, oh, the data sets are pretty similar because they have the same mean or the same average. No, they're very different. Let's take a look at the range. So let's go back and find the range. Now remember, the range, we take the biggest value in the set, which in set A, the biggest value is 14, and we subtract the smallest value. And the smallest value in set A is 9. And 14 minus 9 is 5. So all of the data in set A is within 5 numbers of each other. They're only between 9 and 14. They're all clustered in there together. Let's look at the range on set B. The range on set B, the biggest number is 24. And the smallest number is 0. This set has a range of 24. That's a big difference. That means that there's a difference in the wideness or the spread of the data. Okay, it's much more spread out in the second set. It's not as consistent. Now, there is another type of measure of spread that we'd like to talk about. There's 2 more. And 2 other types of spread that are more specific and give us a little more information than the range would be the interquartile range, which is abbreviated IQR, and that's how you're going to see it all the time, and the standard deviation. Okay, so those are the 2 that we're talking about. Now let's talk about the IQR first. The interquartile range, or the IQR, is the spread that spans the middle 50% of the data. Okay, and what you do is you find the third quartile and the first quartile, and you subtract them. So if you remember your box plots, right, you would take the data there and the number here, and you subtract them, and it tells you how much, what this distance is in here. It tells you what the spread of the middle 50% is, okay? Now we're going to look at something called the standard deviation. This also tells us how spread out the numbers are. Now the standard deviation is used to tell how far, on average, any data point is from the mean of the whole set of data, okay? Now the smaller the standard deviation, the closer the scores are to the mean, the more clustered together they are. When the standard deviation is large, the scores are more widely spread out and further from the mean. So the standard of deviation is calculated to determine how diverse a set of data is. And if you look at these three pictures here, in the first one, the standard deviation is 1, and you can see this is the mean here. Notice how most of the data is in the middle around that mean. When the standard deviation is 2, again, it's pretty much clustered. You know, it's a little more spread out. We've got more space over here, okay? And then when the standard deviation is 3, you can see again, there's more grades over here, more data points over here. The data is more spread out. So the higher the standard deviation, the more spread out. The flatter the curve, the more spread out it got. Okay? Now there is a symbol for the standard deviation that you need to be familiar with, and you're going to see this in your calculator, which I promise is going to make standard deviation easier. It's one you're definitely going to want your calculator for. SX, that's our symbol for standard deviation. And notice you'll also see it's S sub n minus 1. Okay, so how do we find the standard deviation? The standard deviation is the square root of something called the variance. Now the variance, how do we find the variance? The mean difference from each value squared and then averaged is the variance. So we take every data point, subtract the mean, square that number, add it all up, then divide by 1 less than how many we have, and that gives us the variance. Then we square root it to get the standard deviation. That's crazy, right? Wait till you see it in action. Okay, here's a set of data about the presidents and the age when they were elected. And we're going to find the range, the IQR, and the variance so that we can then find the sample standard deviation. Okay, and we are using sample standard deviations because we're not doing the whole population of every U.S. president. We're only doing 6 presidents. So the standard deviation that we always use is the sample standard deviation because we never have the entire population. We're not doing a census. Now, the range, let's start there. The range is the highest, which, what's the largest age? That would be Trump at 70, minus the lowest age, that would be Clinton at 46. And if we do 70 minus 46, the range in the presidents, the last 6 presidents' ages, was 24. Now, let's find the IQR. In order to find the IQR, we're going to want to put the data in order from lowest to highest. So we already said Clinton was our youngest at 46. I'm going to cross them out so I know you used them. Then comes Obama at 47. After that would be G.W. Bush at 54. Then would be George Bush at 64. Then would be Reagan at 69. And finally Trump at 70. Okay. Now, remember, the interquartile was the third quartile minus the first quartile. So the way we do this is you find the median first. You find the middle. So I have 6 data points. So the middle is right here. So here's the middle. Now, let's look at the left-hand side. Just on this left-hand side, what's the middle of the left? Well, that's 47. That's your Q1. Then we go and we look at the right. What's the middle on the right? That would be 69. That's your Q3. So we're going to take 69 minus 47, and that's going to give us 22. That's our IQR. Okay? That's the distance between the middle 50%. Now, let's work on the standard deviation. And we're going to break it down into steps. The first thing we need to do is find the mean of the data. So we need to go back and we need to add up all these ages and divide by how many there are. And there are 6. So we're going to go to our calculator. We have this time. We have 69 plus 64 plus 46 plus 54 plus 47 plus 7. I can add that all up. I get 350. And then we divide by there were 6 presidents. Okay, so that gives us 175 over 3. That's the number I want to use, but I know you guys kind of really want to see what this is. So I'm going to my decimal, and it's about 58. So the average age is 58.333333333. So I'm going to use the 175 over 3. But I'm also going to write down that the average age is 58.333. Okay? Because now what we need to do is subtract each president's age from the mean to find the distance from the mean. So we're going to find out how far away each president's age was from the average age. So I made a table here to kind of help us through this. So I rewrote all the president's ages in here. Okay, so we're going to subtract. The president's age was 69, and we're going to subtract the mean is 175 over 3. Then we're going to have to square that in this column. We'll come back to that. We'll put these in the calculator. Next, we're going to take 64, and we're going to subtract this mean. Then we're going to take 46 and subtract this mean. Now, these are going to give us yucky numbers. I hope you know that. And then it's 54 minus this mean. And then it's 47 minus this mean. And then it's 70 minus this mean. Now, I'm ready to go to my calculator. Okay, so we're going to go to the calculator. And the first one we had was 69 minus 175 divided by 3. So 32 over 3. Now we're going to do 64 minus 175 divided by 3. And that's 17/3. Next we have 46 minus 175 divided by 3. Negative 30. That's because he's younger than the mean, right? So negative 37 over 3, and then it was 54 minus 175 over 3. So again, younger than the mean, so it's negative 13 over 3. Another one of 47 minus 175 divided by 3. We get negative 34 over 3. And finally, we do 70 minus 175 over 3, and we get 35/3. Okay, so we did this and we did this. Now we need to square all these distances. All right, so we need to take 32 over 3 and square it. We need to square 17/3. Now this is why we're squaring. We're getting rid of these negatives. That's why we square and then square root to find a standard deviation. It's going to help us take care of the negatives and make sure the distance is always positive. Negative 13 over 3 squared, negative 34 over 3 squared, and 35 over 3 squared. So here we go. Parentheses. 32 divided by 3 close it, squared. 1024 over 9. Now 17 thirds squared. So parentheses, 17 divided by 3, close it, squared. 289 divided by 9. The negative 37 divided by 3, close it, squared. 1369 over 9. Now it's negative 13 over 3 squared. This is fun stuff, right? Ay, ay, ay. If we have to do this on every problem, this is going to get insane. We'll get like 2 done in an entire period. Now we need negative 34 divided by 3, close it, squared. And you guys are sitting there going, oh my gosh, Mrs. Williams, there's got to be a better way. 1156 over 9, and then 35 divided by 3 squared. And we get 1225 over 9. Phew, okay, we squared them. Now we have to add all the squares of the different distances. So we have to add up that whole column. So we're going to take this whole column and we're going to add it all up. That's the sum of the distances squared. All right, handy dandy calculator, here we come. Phew, okay. 1744 over 3. 1744 over 3. Now we have to take that number and divide by n minus 1. Now n was 6. There were 6 presidents that we had, minus 1, that's 5. So we're going to divide by 5. So we're going back to our calculator and we're going to divide by, so it's taking our answer, and divide by 5, and we get 1744 over 15. Really doesn't mean a whole lot to me, right? And by the way, if I change that to a decimal, it's about 116.2666666 repeating. All right, guys, we still don't have the standard deviation. We're still not there. We now have to take the square root of this. So we're going to do the square root of 1744 over 5. We're almost there. Okay, so we're going to do, where is my square root of 1744 divided by 15, and I'm going to hit enter. Holy cannolis, and it even gave me the decimal. 10.7827. Now usually we'll have you round that to the nearest tenth or the nearest hundredth, so maybe it's about 10.8. So what does this mean to us? It means, on average, the president's ages are 10.8 years from the average age of 58.3. Remember we said earlier that the mean age was 58.3? All right. Phew. Okay. That was a lot of work. Now, there's one more thing I want to look at. Which presidents are within 1 standard deviation of the mean? What on earth does that mean? I always find it best to do this with a number line. And I'm going to put my average, my mean, right here on my number line at 58.3. Now what we're going to do is we're going to take our standard deviation and we're going to add 10.8. 58.3 plus 10.8, that's 69.1. And then we're going to take our standard deviation and we're going to subtract 10.8. 58.3 minus 10.8, 47.5. There we go. Okay, so we could go 1 standard deviation lower, brings us to 47.5. 1 standard deviation higher brings us to 69.1. So all we did is we took the mean, we added the standard deviation, and we subtracted the standard deviation. Now what we want to do is find all of the presidents whose ages are between 47.5 and 69.1. So let's go back and look at that table. Is 69 in that? Yes, it is. 69 is just below that 69.1. What about 64? Yes, that's in there. 46, nope, he's younger than the 47.5, so not him. 54, yep, that's in between those two numbers. 47, nope, that's below 47.5. 70, nope, that's bigger than 69.1. So we have 1, 2, 3 presidents: Reagan, George Bush, and G.W. Bush. So our answer, we have 3 presidents, and they wanted to know which presidents, so we have to name them. They are Reagan, George Bush, and G.W. Bush. And there we go, guys. And I do promise you, there is an easier way to do standard deviation than having to do it by hand. But you're going to have to trust me and use the technology. All right, guys, I'm holding that secret for class. See you soon. Bye.